Okay, so here I'm going to talk a little bit about Bayes' theorem and posterior probability. So to find the posterior probability that event A sub I will occur given that event B has occurred, we're going to apply Bayes' theorem. Bayes' theorem is this expression that you see there, probability of A sub I given B equals, we've got a fairly long expression, but in the numerator it's the marginal probability for A sub I times the conditional probability of B given A sub I. And then in the denominator, we've got to sum up all of those terms. And what are those terms? They're the marginal probabilities for the events A, where here A has their, in this example, n different possibilities. And then, so it's the marginal probabilities of A sub I, in this case, I going from 1 to n, times the probability of B given the A sub I, again, the A sub I going 1 to n for each of those. So that's the expression that we've got for this. And Bayes' theorem applies, or we use it when the events for which we want to compute the posterior probabilities are mutually exclusive and their union is the entire sample space. Then we would use it. So to give an example, we've got a manufacturing firm receives shipments of parts from 2 different suppliers. The quality of purchased parts varies with the source of supply. So one vendor gives better parts than the others were. So it buys 65% of its parts from supplier 1 and 35% from supplier 2. The probability then that a part came from supplier 1 is 0.65, and the probability that the part came from supplier 2 is 0.35. And this just comes from the 65% and the 35%. So historically, 98% of supplier 1's parts are good and 2% are defective, while 95% of supplier 2's parts are good, with 5% being defective. So if we take that information, then we can figure out a conditional probability, or posterior probability if you prefer. And so let's figure the probability that the part came from supplier 1 given that it was defective. So that it came from supplier 1 given that it's defective. So we have to know already that the part's defective. So what do we have here? We have up here the marginal probability of coming from supplier 1. That's in the expression before, that would be the probability of A sub I. A sub I is that it came from supplier 1, times the probability of, in this case, it being defective, given that it came from supplier 1. So that would be, in the expression before, the math term, would be the probability of B given A sub I. And then in the denominator, we have just 2 different possibilities for that A sub I, right? It could either have come from supplier 1 or could have come from supplier 2. So again, probability it came from supplier 1, and then the probability that it's defective given that it came from supplier 1. And then this expression here, the 0.35, is the probability that it came from supplier 2. And then the 0.05 is the probability that it's defective given that it came from supplier 2. So once I have all those pieces set up, I'm able to plug them in. Now it's just a matter of making the calculations. So the 0.02 times 0.65 gives me 0.013, and then so on, also down in the denominator. When I combine all these terms and plug all the math through, I get 0.4262. And you can take a moment and pause and go through with your calculator to just double check that and make sure that all those numbers are right. And you've got that. Okay, so once you've checked that, then I'd like you to go ahead and practice this. So go ahead and pause the video and work through it, and then you can check your answer. But find the probability of something coming from supplier 2, of a part coming from supplier 2, given that we already know that the part is good. And that may take going back and getting the values. Let me go backwards here for just a moment, and getting the values from this page or this set of notes, right? That the probability that it comes from supplier 1 is 0.65, probability that it comes from supplier 2 is 0.35, 98% of supplier 1's parts are good, 2% are defective, while from supplier 2, 95% are good, with 5% being defective. So go ahead and take a minute then and find the probability of it coming from supplier 2, given that it's good. All right, hopefully you found an answer of 0.34296 by plugging in the values using the same formula that we had before and that we used in the previous example.